Okay, here is a practice problem for assignment 17. Hopefully you've looked at the video and taken some notes and may be ready to do that assignment. So here's one last practice problem. Test if the mean number of letters in the last names of Math 240 students is more than 8. A random sample of size 7 from all Math 240 students resulted in a sample mean of 8.4 and sample standard deviation of 1.7. Let's start off by just writing down what is given to us. Well, we are given that there's a sample of size 7, n equals 7. Sample mean, x bar, is 8.4. And sample standard deviation, s, is 1.7 letters. And we are asked to do 4 steps of a hypothesis test. And so the first step is to write down the hypotheses, the null hypothesis and the alternate hypothesis. Okay, so for the hypotheses, we got to fill in what is the parameter that this is about. Well, the parameter is the mean, because we're testing about the mean number of letters. So we put mu in there for both of those. The second thing we want to figure out, well, what is the symbol that is going to go along with mu to give us what the test is? Well, in the null, we can always just put an equals. The alternate, what we're going to put in there after the mu, depends on what we're testing. Well, we're testing whether the mean is more than 8. So that is going to give us a symbol of greater than, because that more than, right, goes along with greater than. And then finally, we want to put in what is the number, the value that we are comparing the mean to. Well, the value that we're comparing it to is 8. So we are testing whether the mean or the mu is greater than 8, more than 8, and that same number is going to go in the null. Now, there is another way that we could write the null. Okay, we always want the equals in the null, and so because we've got a greater than in the alternate, we could put in a less than or equal to 8 here. Either one of those is going to work. So either one of those null hypotheses. Okay, second step that we take in hypothesis testing is to determine the test statistic. So we got to figure out if it is going to be T or Z. So because we have n is less than 30 and sigma is unknown, right? We're not given the population standard deviation. We are going to use T. So our test statistic is whatever we get for x bar minus the value of mu in the null, so mu sub 0, over s, the sample standard deviation, over the square root of n. Okay, so if we plug those things in, we get 8.4 minus 8 over 1.7 divided by the square root of 7. So plugging that into the calculator, we get 0.6225, and it keeps going. And so we will round that to 3 decimal places and get 0.623. Okay, so that is our test statistic. That is our result for step 2. Now, step 3, here is where we want to determine the p-value. So the p-value, remember, is the probability of getting the sample mean equal to 8.4, assuming the null is true. So assuming the null is true, meaning the true mean is equal to 8. Okay, so just a reminder, that is what a p-value is. So we're going to find the p-value using the t-table, the t-distribution table. So we write down what we've got. We've got the t-value equal to 0.623, and we also need to know the degrees of freedom, which is n minus 1. So 7 minus 1, so our degrees of freedom is 6. So we are going to look for the row where degrees of freedom is 6. So I'm trying to highlight just that row with degrees of freedom of 6. Now we look to see where does our t value show up compared to those values that are highlighted. So 0.623, it is actually less than all those values. Okay, so the p-value that goes with those t values is this value here. That would be the p-value. All right. Notice that the p-values, as we go left to right, the p-values go down. So p-values get smaller. Right? It goes from 0.1 to 0.05 to 0.025 to 0.01 to 0.05. All right, so that means as going from right to left, p-values are getting larger. So that means that the p-value for t equal to 0.623, it is going to be greater than 0.10. All right, let's draw a picture. So we know from the table that for the t-value 1.440, that has area in the tail of 0.100. All right, well, our t-value is 0.623. So if we put that on here, we get 0.623. All right, so its area includes that 0.1, but it also includes something more. We do not know exactly what it is, but we do know that that area is more than 0.10. Okay. All right, so that really is all we need to know. So for this third step, we know that the p-value is greater than 0.1. So let's look at step 4 now. That is our conclusion. And we're either going to reject or not reject. Well, we determined that our p-value was greater than 0.10. We want to compare that to our alpha. So how does it compare to our alpha? Our alpha was 0.05. Well, it is greater than 0.05, which is our alpha. Okay, because we know that the p-value is greater than 0.01, that means that it is greater than 0.05. It's greater than alpha. All right, so what's our conclusion? We do not reject the null. That the mean is equal to 8, or that the mean number of letters in the last names of Math 240 students is 8 letters.